Alright, we are going to start with a linear system right here, but we are going to solve systems equations using quadratics and linear. So our parabolas and our lines. But for right now, the warm-up, just talking about two lines there. 2x plus 5y equals 14, whoop, and 4x plus 2y equals 4. So solve the system using elimination. So that means we need to get one of the variables to cancel out. Well, we can do this one of two ways. I'm going to multiply this second equation by -2 so that my x's will cancel out, because -2 times 2x is -4x. We got minus 10y equals -28. We keep the second equation the exact same thing that it was. And when we add them, those cancel out. We got -8y equals -24, divide by -8, and y equals 3. We're not done yet, we need the x value, so either equation will work. I'll use the second one. Plug in that y and solve for x. So that's 4x plus 6 equals 4. Subtract 6 from both sides. 4x equals -2. Divide by 4. And x equals -1/2. So our solution is -1/2, comma 3. So it's an ordered pair, just like we always have for systems. Now, if we would have done this a little bit differently, we could have multiplied both of the equations. And the reason we would do that is to get rid of y first. So 5 and 2, we want them to cancel out. So one has to be positive, one has to be negative, and they need to be the same number. So you're kind of finding a common denominator, or the lowest common multiple, which in this case is 10. So we'll multiply the first equation by 2, and we'll multiply the second one by -5. So we have that -y there. So when we do that, we're left with 4x plus 10y equals 28. And then our second equation will be -20x minus 10y equals -20. So now when we add, the y's are eliminated. -16x equals 8. Divide by -16. X equals -1/2. And then we just plug that back in like we were doing before. So that can go in for either x in either equation. But it's the same idea as what we did in the orange. So this is just a linear system, two lines. So they intersect at one place, one point. Well, what is a system of equations? It's a system with two or more equations that have to be solved at the same time. The answers are ordered pairs. We're looking for an x and a y value of where they intersect. We'll learn 3 ways to solve these: graphing, substitution, elimination. Today we'll be doing elimination. And again, kind of like what we did in the warm-up. So there could be 3 different types of solutions, or 3 different ways to look at these problems. Either there's 2 solutions where we have our parabola, the red, and our line, the blue, and they're just right there. The intersections are at -2, 0, and 1, -3. And those would be the solutions. That's it. In this one, we only have one solution. That would be at 0, -2. Because the line just touches the vertex, but not anywhere else. And of course, we can have no solutions where the parabola is either opening up and above the line, or opening down and below the line. So we have the 3 different forms of solutions, just like we saw with regular quadratics. So to do elimination, you need to eliminate one of the variables by adding equations. So you can multiply one or both equations by a constant to obtain coefficients that are differential in sign for one variable. So they're the same number but opposite signs. And that's what we did in the warm-up. We're doing the same thing now. Then add them up, combine like terms, solve for the variable that we're missing, plug it back in to get our other coordinate of our solution. And we'll have to do that twice because we're going to have, most of the time, we're going to be looking at two solutions. So we'll have to just do it twice, but it's really no different than what we've already been doing. So let's go and try some examples. So when we solve using elimination, usually the variable that we want to cancel out, or the easiest way to do it, is to cancel out the y. So we want to cancel the y variable. So in this first system, if we look at the y's, we got negative 2y and positive 1y. Well, we want them to cancel out, so we're going to multiply the second equation by 2. And I always like to rewrite these equations so that they're all lined up and nice. Negative 4x squared minus 6x minus 2y equals 4. And when we multiply that second equation by 2, there is no x squared, so I'm not going to put anything underneath here. But 2 times 2x is positive 4x. 2 times y is a positive 2y. And 2 times negative 3 is negative 6. So that when we do just add straight down, we still have the negative 4x squared. Negative 6x and 4x is a negative 2x. The y's cancel out, which is what we want. And 4 and negative 6 is a negative 2. So now we only have one variable. And we have an x squared, and that's what our whole last unit was on. So we should be able to solve this. So first thing we want to do is add 2 to both sides. Negative 4x squared minus 2x plus 2 equals 0. Notice I didn't add the 2 with the negative 2x or the negative 4x squared. They're not like terms. Don't do that. So now we need to solve this. Several different ways, but I think the most prevalent and probably the most important method is factoring. So first off, we ask for a GCF. Is there one? Yeah, there is. We don't want our first coefficient, or our coefficient of the squared term, to be negative. It just makes factoring very messy, and we don't need to deal with that. So we're going to take out a negative, and 2 goes into 4, 2, and 2. That is our greatest common factor. So when we take that out, we have 2x squared minus x minus 1 equals 0. Well, our GCF is just a constant, negative 2, so negative 2 times 2x squared minus x minus 1 equals 0. So if we multiply two things, one of them has to be 0. Well, negative 2 can't be 0. It's negative 2. So we kind of ignore the GCF as long as it doesn't have a variable in it. Now we need to factor this. So we can just do, see if I can put it somewhere, a diamond problem. We multiply the first term and the last term to get our product. And the middle term, which is really a negative 1, is in our denominator. So what two numbers multiply to negative 2 and add up to negative 1? You get negative 2 and positive 1. Now, unfortunately, because our coefficient of x squared is not 1, we can't do the shortcut for factoring. We got to do the long ways. So, 2x squared is still there. Instead of negative 1x, we're going to split it up into those two. Negative 2x plus 1x minus 1 equals 0. Whoop. And this is kind of separate. So now we factor by grouping. And we don't need the 1 in front of the x, but I think it helps when we're factoring just to see what we can take out. So in the first set, we can take out a 2x. We're left with x minus 1. 1x minus 1, can we take anything out of it? Well, we can always take out 1, and we're left with just x minus 1 again. There's no difference there. So now we still have factors. 2x times x minus 1 and 1 times x minus 1. So we're going to take out the GCF of both terms, which is x minus 1. Once we take that out, our leftovers, 2x plus 1 equals 0. So now we set these equal to 0 and solve for x. So we add 1 to both sides, we get x equals 1. Pretty simple. We would subtract 1 and divide by 2 to get x equals negative 1/2. So both answers are correct. They're not done, but they are correct. So what we still need to do is substitute those values back into one of the equations, either one, and get our y values that go with those x values. So I want to use 2x plus y equals negative 3. Why do I want to use that? Because it's easier than a quadratic. So 2 times 1 plus y equals negative 3. So it's 2 plus y equals negative 3. Subtract 2 from both sides, and y equals negative 5. So one solution is 1 comma negative 5. Now we're going to substitute in the negative 1/2. So 2 times negative 1/2 plus y equals negative 3. 2 times negative 1/2 is just negative 1. Plus y equals negative 3. Add 1 on both sides. Y equals negative 2. And so we have our ordered pair. Negative 1/2 was our x, that's what we substituted in. And y is negative 2, what we got when we solved for y after we substituted the x value in. So that's what we're doing with these problems. We need to just find the solutions that make both equations true. So I think example 2 is probably going to be a little bit more straightforward. Solve the system using elimination method. Well, if we look at this right off the bat, it's lined up, and the y's are going to cancel out when we add it up. So we don't have to multiply them by anything, we don't have to change any of them, just add straight down. So we got x squared minus 2x. Those cancel out. Equals 3. Well, we want everything on one side of the equation so that it equals 0. We can find our zeros. You can use the quadratic formula. You can complete the square on this one if you want. You can't do radicals, but I think the easiest thing to do and the quickest thing to do is factoring, if we remember that. So remember, the coefficient of x squared is 1, so 1 times negative 3, negative 3 of course, and negative 2, our linear term, our b term, is the sum. So what two numbers multiply to negative 3 and add up to negative 2? Negative 3 and positive 1. And because the x squared's coefficient was 1, we can skip right to here using our diamond problem answers. So we don't have to worry about factor by grouping and everything we did in the last problem. Now we set both equal to 0. I'm hoping that we don't need to go step by step to solve for x. 3 to both sides, x equals 3. Subtract 1 from both sides, x equals negative 1. So we have our x values, we got to plug them back in to get our y values. So negative 3 times 3 plus y equals 1. And again, you could plug it in to the first equation, but it's much easier this way, less work. And then we'll do negative 3 times our negative 1 plus y equals 1. So just real quickly, we multiply, then we add, we get y equals 10, so that would be 3 comma 10. That's one solution. The other one, negative 3 times negative 1, is 3 plus y equals 1. We subtract 3 from both sides, and y equals negative 2. So our other solution is negative 1 comma negative 2. And that's it. Just keep doing this over and over and over again. So let's travel back. We'll look at the third example. let's use blue. So they're kind of lined up, but if we add down, nothing's going to, well, the x's might cancel out, but really we want the y's to cancel out. Because if we cancel out the x's, we still have an x squared term, we still have y terms, so we still have two variables, and it's not going to help us much. So I'm going to multiply, guess it doesn't really matter. Start this work, there we go. Multiply this second equation by -1. That way, when we compare the y and the y variables from both equations, one's positive, one's negative. So again, first equation, I'm not changing anything. Technical difficulties, I apologize. So we got minus x plus 3, and now we have negative y equals negative, whoop. Let's not put the negative x there, let's put it under the other x term. Now we have positive 1. So again, when we add those, the y's cancel out, it equals 0, which is what we want anyways. Negative 2x squared is still there because there's no other x squared term to add. Negative x and negative x is negative 2x, and 3 and 1 is 4. So, first off, again, we're going to do this by factoring. Our GCF is negative 2. So I take out the negative 2, I'm left with x squared plus 1x minus 2. So I put that 1 in front of the x just so we know there's a 1 there that is 1x, not just none. And again, like we saw before, negative 2 times this equals 0. Well, that means either one of these equals 0, but negative 2 can't. That doesn't make any sense. So we ignore it, and then we just factor. So if we do our diamond problem, two numbers that multiply to negative 2 add up to 1, be 2, and negative 1. And again, because the coefficient of x squared here is 1, even though it's not really written there, we can skip right to here, which is always nice. Then, set each one equal to 0 separately. So in our first equation, we get x equals negative 2. In the second, we get x equals 1. So we're halfway there. X is probably a little bit more. We did more of the work. Now we need to substitute in the negative 2 and the 1 in for x. And that second equation is the best and probably easiest. So y equals x, so negative 2 minus 1. Well, that's negative 3. So negative 2, negative 3 is one solution. Then I substitute in the 1. So it'll be 1. Oops. 1 minus 1. Or 0. So our x value was already 1. Now we have a y value of 0. That's our other solution. Not really that bad. So let's keep on moving. Let's go orange. Solve the system using elimination method. Again, same thing. I'm going to multiply the second equation by negative 1. So again, so the y's cancel out, and I think that's easier. Y equals x squared. I'm going to leave a spot for my x term, which is really 0x, and then minus 9. You can write 0x if that helps you. I don't think it'll hurt you. When we multiply the second equation by negative 1, get negative y equals 6x plus 17. Notice I skipped that first spot. You could write 0x squared, but you don't really need to. Just like you don't really need to write that middle term there. Now we can just add down. Y's cancel out. X squared is still there. There's no like term for it. Same with the 6x actually. This is a kind of different one. Negative 9 plus 17 is a positive 8. Now we have our equation that we need to solve. And we do our diamond problem. There is no GCF in this one. We want a product of 8 and a sum of 6, so that would be 4 and 2. And because the coefficient of x squared is 1, we can go right from the diamond problem to the factored form of it. X plus 4 and x plus 2. Set each one equal to 0. So x equals -4 and x equals -2. Kind of skip some steps. If you really need to see those, you can ask me in class or email me, but hopefully that's pretty straightforward. So we got our x's. We need to substitute them in for the y's, or for the x's. And either equation is fine. I'm actually going to use the first one this time, because why not? So it's x squared, or -4 squared, minus 9. That'd be 16 minus 9, grand total of 7. So -4, 7 is one of our solutions. Now we do the other x value, which is -2. -2 squared is 4, minus 9, -5. So we have a solution of -2, -5. And we got both of our solutions. Remember, and I didn't mention this, whenever you square a number, whether it's negative or positive, you get a positive number. Just because you're squaring a negative does not mean you get a negative. That's why I substitute in with parentheses. All right, let's look at this last one on this page. We'll do the same thing. I think it's probably easier to multiply, well, I guess it doesn't really matter. Let's multiply the first one, the first equation, by -1. So we get -y equals positive x squared plus 4x plus 1. We didn't change our second equation. There's no x squared, so I'm going to skip that spot. Minus 2x minus 4. And now I'm just going to add straight down. Y's cancel out, which is what we wanted. X squared is still there. There's no like terms. 4x minus 2x is a positive 2x, and 1 plus -4 is a -3. So we have our quadratic that we have to solve. So once again, we check for a GCF. There is not one. So our product has to be -3. Our sum has to be 2. So that would be 3 and -1. And again, the coefficient of x squared is 1. So we can skip right to here. Again, hopefully we can see that if x plus 3 is 0, then x is -3. And if x minus 1 equals 0, x equals 1. Just little equations, one-step equations. Now we need to substitute those back in to find y. Second equation's easier, it's only got 2 terms. So that's what I'm going to do. So y equals -2 times -3 minus 4. That would be 6 minus 4, or 2. Then -3, oops, -3 comma 2 is our first solution. Our second one, substitute in 1 for x. So that's -2 minus 4, or -6. So our second solution is 1 comma -6. So that's what we're doing when we're dealing with our systems. All right, we have 4 more problems to go. So let's just get on it. Again, we need to multiply one of these equations in number 1 by negative so that our y's cancel out. Doesn't matter which one. So let's multiply the second one by -1. I'm going to rewrite my first equation. I didn't change anything with it. I just want to have it in better shape and better order than with the second equation now. So -1 times -y, or times y is -y. No x squared. Positive 2x now, and a -2. So now we can add down, the y's cancel out, which is what we want. -2x squared is still our x squared term because there's no like terms. 2x and 2x is 4x, and 8 and negative 2 are positive 6. So, GCF, yeah, we got a negative 2. So when we take out that negative 2, we're left with x squared minus 2x minus 3. And again, when we have a GCF that doesn't have a variable, it doesn't really mean anything. So now we do our diamond problem. The product would be negative 3, and the sum is negative 2. So the two numbers that work for that are negative 3 and 1. And because our coefficient of x squared is 1, now that we took out the GCF, we can skip right to here. And of course, that equals 0. Hopefully, we can see this first equation gives us an x value of 3, and the second factor gives us an x value of negative 1. Set them equals 0, do your opposite operation and get x by itself, and that's what you end up getting. So we have the x values, but we need the y values. And both of these equations are kind of nice the way they're set up. It's y equals, so all you have to do is plug in the x and just tell me what it equals. So y equals negative 2 times x, which is 3 in this first case, plus 2. Well, that's negative 6 plus 2, so negative 4. So our solution is 3, negative 4. Or at least our first solution is. Our second solution, we got to substitute in negative 1 for x. So y equals negative 2 times negative 1 plus 2. So that's just 2 plus 2. Hopefully we see that that is 4. So we have a solution of x is negative 1 when y equals 4. So that's our second solution. And we're all good now. So we got a couple more. Let's keep trying these. The second one, again, let's multiply the second equation by negative 1. We'll rewrite the first equation, especially since it's spaced out weird. And then negative 1 times y, negative 1 times 5x, and negative 1 times negative 1. No x squared term in the second equation, so I skipped it. Equals 0. X squared minus 9x minus, oh, we got a typo here. It should be plus 7. So when we add 7 and 1, we got a positive 8. That's the equation we want to solve. So again, we do our diamond problem. We want a product of 8, sum of negative 9, so that would be negative 8 and negative 1. And because our coefficient of x squared is 1, we can skip right to our factoring, our factored form, x minus 8 and x minus 1. Set each of those equal to 0, solve for x, so x equals 8, x equals 1. Now we just have to substitute them in. And again, that second equation is the best way to go, I think. So y equals 5 times x, which is 8 in the first case, minus 1, is y equals 40 minus 1. Of course, that's 39. So our first solution is 8, 39. Find our second solution, we substitute in 1 for x. Kind of running out of space here, so I'm going to jump up here. So y equals 5 times 1 minus 1. That's just 5 minus 1, or 4. So our second solution is x is 1 and y is 4. So not too bad. Hopefully we're getting a better handle on this. Hopefully we can get some better factoring with this as well. All right, let's look at this last one up here. Notice the y's are already set up to be canceled out. So all we have to do is add down. We get 5x squared, because there's no x squared in the second equation. Negative 17x and 10x is negative 7x. The y's cancel out, and 1 and negative 3 are negative 2, or is negative 2. We're going to add 2 to both sides so that we can get it all equal to 0. Now 2 is not a like term with 5x squared and negative 7x, so you can't add them. We just put it as our constant at the end. Now, we got to do our diamond problem. I guess first we should check, is there a GCF? Well, 2 doesn't have an x, and the only thing goes into 5 or 7 is 1 in itself, so that's not going to work. So remember, for our product, it's the first coefficient times the constant, so 10. And we want them to add up to negative 7. So that'd be negative 5 and negative 2. But because our coefficient of x squared is not 1, we can't do the shortcut. We actually have to split up that middle term into minus 5x and minus 2x, keep the plus 2. So again, we just turned these two into these two, and then we group them. Again, factoring is probably the easiest way. Quadratic formula works, but I think that takes a little bit longer. Completing the square on this one would be very, very messy. So factoring is the way we want to go. So we factor out a 5x in that first case, so we're left with x minus 1. We can factor a negative 2 out of the second set, and we get positive x minus 1, because 2 divided by negative 2 is the negative 1. Still equals 0. And now, oops, let's take out our common factor first. Our GCF for this is x minus 1. It's in there twice. It is a common factor. So once we take those out, we're left with 5x minus 2, that's our leftovers, equals 0. So x equals 1 from this first equation. The second equation is not quite obvious. So let's write that one out. 5x minus 2 equals 0. Add 2 to both sides. And then divide by 5. So x equals 2 over 5. So not an ugly answer, but not really nice looking either. So we have our two x's, but we need our two y's. So 10 times x, which in this first case was 1, plus y equals negative 3. So that's 10 plus y equals negative 3. Subtract 10 from both sides, and you get y equals negative 13. So our first solution is 1 comma negative 13. Second equation, we need to substitute in 2 over 5, or second solution I should say. So 10 times 2 over 5 plus y equals negative 3. If you were to substitute 2 over 5 in for x in the first equation, you have to square it, you get 4 over 25, and it's just ugly. So it's easier just to use the second equation. 10 times 2 over 5 is 4, plus y equals negative 3. We subtract 4 from both sides, and y equals negative 7. So our second solution is 2 over 5 comma negative 7. So that's how we solve our systems, our linear quadratic systems. Same thing, once we get rid of the y, it's the same thing we've been doing for the last 5 months. Should be starting to click. All right, our last question for the day is error analysis. Ricky used elimination to solve a system, but his work is incorrect. Find and correct his error, then solve the system. Well, if you look at this, it's very subtle. So they multiplied the second equation by negative 1. So again, we get this. And now we have negative y equals negative 3x minus 1. So what do we get when we add those up? Well, and hopefully you guys didn't fall for it, these two are not like terms. And that's what Ricky did wrong. He combined those two. He added them like terms, but they're not. X and x squareds are completely different things. So let's rewrite this one more time. Actually, let's rewrite it over here. So y equals 2x squared. I'm going to leave a spot, then plus 3. And y equals, I'm going to leave a spot because I don't have an x squared term, 3x plus 1. Oops, we wanted to multiply that by negative 1. So negative y, negative 3x, and a negative 1. So y minus y is 0. 2x squared plus nothing is 2x squared. Nothing minus 3x is minus 3x. And 3 minus 1 is 2. So we have positive 2, so we have our quadratic. Do our diamond problem. First coefficient times our constant. Our sum is the negative 3. So what two numbers multiply to 4 and add up to negative 3? Well, what are the numbers that make up 4? 1 and 4, 2 and 2, and that's it. Is there any way we can get a 3 from those? Well, yeah, maybe if we use 1 and 4, but the 4 would have to be negative, but negative 4 times 1 is a negative 4. So this cannot happen. So another way to solve for x, it can't be factored, is to use the quadratic function, the quadratic equation. So negative b plus or minus the square root of b squared minus 4ac all over 2a, where a is 2, b is negative 3, and c is 2. So I'm going to use that to solve for this. So negative b plus or minus b squared minus 4 times a times c all over 2 times a. So all I did was substitute in the values a, b, and c. Now I need to work this out. Of course, negative 3 is just positive 3. Negative 3 squared is positive 9. Don't tell me 6, and don't tell me negative. Negative 3 times negative 3 is positive 9. Negative 4 times 2 is a minus 16 or plus a negative 16 over 4. So we got 3 plus or minus the square root of negative 7 over 4. Now right here you should realize something. We should realize that we have a negative inside the square root. Or really our discriminant is negative. So hopefully remember from this unit or a past unit that if we have a discriminant that's negative, we have complex solutions, but since we're trying to find ones that work for both of them, we don't have any. So there are no real solutions. And it's just no real solutions because we have a negative here, we'd have to have I, and then obviously it's not a real number. So sometimes we have to use a quadratic formula, sometimes we can't even get solutions. And we saw that in the notes all the way back here. So that last one looked like this, something like that.